Welcome to This Explainer. Today we're going to do something pretty fascinating. We're going to put on our clinical endocrinologist hats and watch exactly what happens inside your body when you drink a simple, sugary soda. Now, to most people, a soda is just a nice, quick refresher on a hot day, but to an endocrinologist, well, we see a potent, fast-acting chemical trigger that demands an immediate full system response. So we aren't just going to vaguely talk about sugar rushes today. We're actually going to map out the precise minute-by-minute biological cascade that takes over your entire system. This is the anatomical reality of your body experiencing a 60-minute systemic metabolic event. To give us a clinical baseline, we're looking at a standard can of soda, which contains roughly 39 grams of sugar. To bring that abstract number into sharp reality, that's equivalent to eating 10 whole sugar cubes in a matter of seconds. To your body's regulatory systems, this isn't just a beverage, it's literally a massive metabolic load. It's a highly concentrated, overwhelming dose of chemical information that your body not only has to react to, but actively anticipates from the very first drop. Okay, let's dive right into this and ask the core question. What exact clinical emergency unfolds across your major organ systems over the next hour? Because over the next 60 minutes, this massive influx of sugar is going to touch your brain, completely alter your blood chemistry, push your pancreas to its limits, overwhelm your liver, and trigger your fat cells. The timer is about to start.
Before we start that clock, we really need to understand the molecule we're dealing with. The sucrose in that can functions like a two-piece biochemical jigsaw puzzle. The second it enters your system, it splits into two fiercely distinct paths. First, we have glucose. This is your body's preferred cellular fuel, shared by billions of cells, but it has a catch. It strictly requires the hormone insulin to act as a key to unlock your cells so it can be used. Then we have fructose, the other half of the puzzle. Fructose is a highly complicated molecule with a very specific anatomical destination. It completely ignores your general cells, rotting directly via the portal vein and dumping a massive biochemical burden solely on your liver.
Let's move to our timeline and see how this builds, starting right at minute 0. The journey kicks off the exact microsecond that sweetness hits the specific receptor cells on your tongue, known clinically as T1R2 and T1R3. At this exact moment, you are officially a passenger in your own body. Your conscious brain is effectively cut out of the decision-making process before you've even fully swallowed the liquid.
In a terrifyingly fast 30 milliseconds, which is quite literally faster than the blink of an eye, a signal fires rapidly through your cranial nerves. It completely bypasses simple taste recognition and slams directly into your brain's primal reward center, the nucleus accumbens. The physiological cascade has started, entirely without your permission.
This brilliantly illustrates our evolutionary wiring. From an endocrinologist's perspective, your brain is currently being hijacked. It genuinely thinks you've just stumbled upon a miraculously rare, life-saving berry bush in the Paleolithic wilderness, rather than simply cracking open a mass-produced can of soda. This neural activation triggers a massive dopamine rush, chemically rewarding you before a single molecule has even reached your stomach. That first sip bliss you feel? Yeah, that's pure neuroscience, guys, not a lack of willpower. Tracking forward to the 5-minute mark, the liquid hits your stomach and small intestine. Because it's a simple sugar, it bypasses normal complex digestion entirely. It's like dropping a sugar cube into a glass of warm water. It just instantly dissolves and begins crossing the wall of your small intestine directly into your bloodstream. The clinical risk here is that there's absolutely zero digestive buffer. This unchecked velocity creates an aggressive, unnatural, and incredibly steep climb in your blood glucose levels. This sudden, violent flood of glucose forces your pancreas, specifically the incredibly hardworking beta cells within the islets of Langerhans, to sound a system-wide alarm. They rapidly secrete insulin. You can think of insulin as a VIP security pass. Every cell in your body has a locked door on it, and insulin is the vital key that your starving cells desperately need to let the floating glucose inside. Without it, the fuel is useless and dangerously builds up in the blood. And right now, those beta cells aren't just working, they are redlining to keep up with the unnatural influx. As we hit the 20-minute mark, the system is becoming totally overwhelmed. A 39-gram wave of simple glucose arriving in under 10 minutes is just not a natural evolutionary scenario. To handle this sheer volume, your pancreas is officially operating in a state of full-blown clinical emergency. It's pumping out massive, unprecedented amounts of insulin in a desperate attempt to force all that glucose out of your bloodstream and into your tissues before it causes cellular damage. But this biological panic leads to a severe, unintended consequence. The pancreas overcorrects.
In its sheer urgency to bring your spiking blood sugar down from dangerous heights, it floods your system with a massive excess of insulin. This aggressive overshoot sets the exact clinical stage for a condition known as reactive hypoglycemia. By forcing too much glucose out of your bloodstream too quickly, your blood sugar is driven violently below its normal, healthy baseline. And because your brain relies almost exclusively on glucose for fuel, it basically begins to starve. This is exactly why you might experience sudden shakiness, a wave of anxiety, or lightheadedness after a sugar binge. It's your central nervous system sending out a terrifying distress signal.
While this loud, systemic glucose emergency is unfolding between minutes 20 and 40, we have to look at the other half of that sugar molecule, the fructose. Fructose completely ignores the general bloodstream. Instead, it's quietly traveling via the portal vein straight toward a single destination, your liver. Why the liver? Well, because your liver is the only organ in the entire human body capable of processing it. It holds a highly specific hepatic enzyme called fructokinase. So, unlike glucose, which is shared across billions of cells, the entire fructose load from those 10 sugar cubes lands on just one single organ, all at once. Imagine trying to funnel a 4-lane highway of speeding traffic into a single toll booth. That bottleneck is exactly what is happening inside your liver right now with fructokinase. This beautifully illustrates the silent clinical risk of severe liver stress. In a normally fed person, the liver's energy tanks, its glycogen, are already completely full. So, essentially being force-fed, the liver has absolutely no choice but to take this sudden fructose deluge and convert it into triglycerides. Over time, this mechanism literally accumulates invisible fat directly inside the organ itself, acting as a primary driver for non-alcoholic fatty liver disease. Your liver is quietly struggling with a chemical load it was never biologically designed to handle. Moving to the final phase, around 45 to 60 minutes, the two distinct pathways, the glucose overshoot and the fructose processing bottleneck, culminate. That massive insulin overshoot we detailed earlier has now driven your blood sugar into a dangerous, precipitous dip. It's severely undershot your baseline. And your body doesn't view this as a mild inconvenience. Because the drop is so rapid, your body literally interprets this undershoot as a severe systemic crisis. It genuinely thinks you are suddenly starving to death. The crucial point here is this predictable, highly documented craving loop. The excess of insulin violently drags your blood sugar into a crash. To prevent you from losing consciousness, your adrenal glands panic, forcefully dumping stress hormones like cortisol and adrenaline directly into your blood. This potent chemical cocktail then forces your hypothalamus to desperately scream for more rapid energy to fix the low fuel supply. Have you ever wondered why you can eat a massive sugary treat and somehow feel ravenously hungry, shaky, or irritable just 2 hours later? Sugar doesn't just feed your cravings, it creates them. That mid-afternoon brain fog, the irritability, the sudden desperate reach for another sweet snack at your desk, that is a direct biological consequence of the very first drink. Your internal chemistry was just flawlessly manipulated to demand a repeat. It's a closed physiological loop. Section 1, Breaking the Sugar Cycle, Blunting the Biological Spike. Now that you understand the exact, uncompromising endocrinology behind this loop, we can look at how to protect your liver and stabilize your blood sugar. The biological solution is entirely about blunting the spike. Your body isn't inherently poisoned by sugar, it just completely struggles with the unnatural speed and volume of liquid calories. By actively pairing your sweets with dietary fiber, healthy fats, or robust protein sources, you create a literal physical roadblock in your gut. Fiber, for instance, creates a viscous matrix in your intestines, trapping the sugar and forcing it to be absorbed incredibly slowly. This turns a dangerous flash flood of glucose into a manageable, steady stream. This simple act gives your pancreas the grace to respond proportionally, rather than panicking and triggering that devastating insulin emergency. You now possess the powerful clinical understanding of your own internal metabolic clock and exactly how to control it to prevent reactive hypoglycemia and liver stress. But to leave you with a provocative thought for our next explainer. What extraordinary, almost unbelievable biological cascade begins the exact millisecond you push too hard at the gym and physically tear a muscle? Join us next time to find out.